Welcome to Study Loop.
So we're going to start by using Lagrange multipliers to solve the problem. So what we have is that f of xy equals 2x plus 3y, and that g of xy equals the square root of x plus the square root of y, which is equal to 5. So we have, we want to set the gradient of f, which is 2, 3, equal to lambda times the gradient of g, which is going to be lambda times 1 over 2 root x, 1 over 2 root y. So what we see based on this is that 2 equals lambda over 2 root x. So x, the square root of x equals lambda over 4. And then using similar logic, we see that the square root of y equals lambda over 6. Then we substitute the values into our constraint equation, and we see that the square root of x plus the square root of y equals 5. And in this case, we have lambda over 4 plus lambda over 6 equals 5. So that gives us that lambda equals 12. Now taking it back, we see that the square root of x equals 3. So that means x equals 9, and the square root of y equals 2, so y equals 4. Those are important values right there. And then the only possible extreme value subject to constraint is f of 9, 4, which equals 30. So then for part B, we want to see f of 25, 0. That equals 50, and we see that it is larger than 30, which was in part A. So for part C, we want to look at the level curves. And just to draw it, what we see is if this is what we have right here, we have level curves that look like this, but the main focus is on this level curve right here, which this is the point 94, and we see that this is f of x, y is equal to 30, and therefore the maximum value is f of 0, 25. F of 0, 25 is this point up here, and that is equal to 75. So the reason why Lagrange multipliers fails in solving this problem is because, as we can see, it was not able to get us the right maximum. Typically we use Lagrange multipliers to find a maximum, but in this case it didn't. So that is why it failed. Then we want to look at the significance of 9, 4. So we know that 9, 4 was the point that we got previously up here, 9 and 4. And this point is significant because, as we've seen from the level curve, it is the absolute minimum of f subject to g. So right here, it's this value right here, it's the absolute minimum.